Recording in progress. All right. Thank you guys for joining. If I may introduce Leah Moran. She hails from Nashville, Tennessee, and she is currently working on her PhD under Dr. Sammy King and Andy Nyman, studying secretive marshbirds and wetland ecology. But before adventuring down the bayous, she got her bachelor's at the University of Tennessee, Knoxville in wildlife and fisheries sciences. And also has worked on a plethora of shorebirds and waterbirds in Florida and New Hampshire, gained a master's at Mississippi State University, studying double-crested cormorant colony effects in Guntersville, Alabama, and worked for U.S. Department of Agriculture in Alabama as well, specifically looking at human wildlife conflicts and rabies prevention. But tonight, she will talk more about her doctoral research. Okay, thank you so much.
Thank you all for having me. I'm happy to be here, and I am especially happy to kind of give you an overview of my dissertation project, which you can see is looking at the patterns and processes behind secretive marshbird abundance and movement in southeastern Louisiana. Which is basically just the Deltaic plain of Louisiana is where my study took place. Come on. There we go. Okay. So just you get a little cut off over there, but I just want to start out with a little bit about Louisiana's coast. I'm sure you guys already know this, but Louisiana's coast has seen a lot of land loss, especially since 1932. We've lost approximately about 5,000 square kilometers of the coast, and it's projected by 2100 we will lose another 7,700 square kilometers. So, which is unfortunate. And to compile bad news on top of bad news, we also deal with a lot of other anthropogenic disasters. One of those are, of course, oil spills due to the oil and gas industry across the coast. Probably the most well-known one was the Deepwater Horizon Oil spill in 2010. And during the aftermath, when there was recovery going on, they only detected 32 marshbird mortalities, which is obviously an underestimate, but because there have been no systemic surveys done in this area ever, they couldn't say that there were more mortalities or effects on these birds. So because of that, and after the BP settlement, the Louisiana Technical and Implementation Group decided that they wanted to effectively restore Louisiana's secretive marshbird populations into the future. And so this is where my project stems from. It is basically to look at where these birds are on the landscape, why they're there, and from that get an estimate or abundance and species distribution models of where these birds are in southeastern Louisiana. And with that as well, this is like the projected future without action. As you can see in red, that is all land lost in the next 50 years. And this is just the medium scenario. And so because of this, the state, as we all probably know, implemented the coastal master plan for the whole entire coast. And what I really want to point out with this is that there are multiple projects, and the colors here, as you can see, marsh creations, diversions, restoration. But the ones in light green, those are the marsh creation projects, and those account for $16 billion out of the $25 billion budget. That's a lot of money to put land and marsh on the landscape. And so if we want to do this effectively, we have to make sure that what we are building is appropriate for the animals that actually use these areas. And so with this, I'm a little messed up, if that's okay. We have to understand how wetlands function. And so a wetland basically has three components. There's the hydrology, the vegetation, and soils. And within these three things, we have the patterns and processes that make the processes that make the patterns. And so patterns are basically what we see on the landscape. They're tidal creeks, they're ponds, and they're the salinity gradient from coastal marshes, the salt marshes, all the way to fresh marshes. And we have our vegetation, which is the species we see, the communities we see, and the density. So basically how dense that greenness is there. And soils are a little bit harder to see the patterns, but those include like the ponding, the edge on the habitat, and the soil horizon when you dig into actual marsh itself. And all of these create the landscapes that we see, or the coastal marshes that we see. And this includes the edge and cover water ratios. But how do we get to these patterns? We have the processes behind them, which again, with hydrology, that could be the duration, how long a flooding lasts, the variability, how long does it happen, and the depth, how much water do we get. For vegetation, there's the productivity of the vegetation, diversity and succession, soil, subsidence, dreaded subsidence, but we also have accretion, biogeochemistry, and erosion. And I apologize, I don't know why it got messed up from my computer to this one. So with these, our birds, our secretive marsh birds, they are reacting to all of these, to the patterns and the processes. And we often in the past have looked at how birds respond to patterns because it's easier. It's what we can see and we can measure this. But it's also really important that we understand the underlying processes and how these birds are reacting to these. And as technology kind of gets up to what we can use, we can actually look at that, which is what I plan on doing. So for our 3 objectives, they kind of vary spatially, or they kind of get bigger as the objectives go on. My first one is to look at how to quantify the effects of vegetative patterns and hydrological processes on the home ranges and movements of these birds. And these are specifically for the gallinules and rails we find on the coastal marshes. The second one is to look at the abundance. So basically the effects of landscape patterns and processes on marshbird abundance at points we did surveys at. And the last objective, which I won't get into today, just because 1, for time, but 2, I haven't actually looked at it yet, still in the process. But that is to make a species distribution model of abundances of marshbirds within southeastern Louisiana. And this is for future, if any oil spills do happen or any other disaster happens, that the state and federal agencies could potentially use this to get better compensated for restoration into the future. And so first, I'm just going to start with my first objective, and that is again for my home ranges and movements. To do that, we had to capture some birds, which is very fun. At the end of it, we captured 23 rails, and this includes king rails, flapper rails, and also for our brackish and intermediate marsh, where we can't tell the difference of whether it's one or the other, we just called them cling rails. And we also caught 25 gallinules, and that was almost split half and half within common gallinules and purple gallinules. And for both of these, we kind of had a dual-ended question. One was looking at net square displacement. And so what basically this does is you take a reference point and see from that how far a bird moves from that reference point and whether it comes back or whether it completely leaves that area. And we wanted to see if hourly water levels from that location coincided with that displacement. So is there a correlation? Is water levels making these birds move or not? The second part of this objective was to look at home range size and what could be affecting that using generalized linear mixed models. For the home range, we looked at the vegetation community present, again, the water variability, the normalized difference vegetation and water index, which I'll just call NDVI and WI from now on, and median and max water levels from where these birds were captured. So I also wanted just to kind of give you an idea of how we captured these rails. Dual-ended, we used mist nets with a V-net formation. And with these, we had a speaker at the junction of these nets to basically call the birds in during spring breeding season. So that's when they're obviously very territorial. So they get caught in the net and we can obviously catch them. We also used noose carpets because we realized it was probably going to take us about 5 years to catch 23 rails. We only did it that way. These caught a lot more rails than we expected, even in fresh marsh. It was very productive for us. So you basically use the same setup. You have carpets of these, and then you lure them in with a speaker of a rail calling, which was pretty fun, if I do say so myself. And once we did catch them, we obviously put a 6-gram transmitter on them that had a solar panel. So a lot of these gave us location data for up to 3 years, which is pretty great. We also banded them and took morphological measurements of every bird that we caught. And I will say for both our rails and gallinules, we only banded and tagged adults, no juveniles. For our gallinules, we did something a little different. We used airboats at night. To basically spotlight them and then hoop net them. And so once the people got about 3 gallinules into a bag, they came back to our deployment site where we worked them up and put, again, our transmitters banded and took morphological measurements. And so for our water levels, how we decided to use that data, there's actually coastal reference monitoring system stations across the coast of Louisiana. It's publicly available. They have water levels, community types of vegetation, salinity, anything you can think of. They're really a great source of information for Louisiana, and it's a great benefit to researchers and to everybody else. So we downloaded all those water level datas and the vegetative communities associated with them. And where we did need to supplement any areas where there were no CRM stations, because we did trap on created marshes, we used our own water loggers to gain hourly water levels. And we also used drone imagery, one to ground truth those vegetative communities, but also where there are no CRM stations, so we could get that vegetative community as well. So for our results, I'm just going to go by species. I'm first going to talk about king rails. Displacement or movement was negatively correlated with water for these species. And this was for across seasons and across years. So as you can see here on the y-axis, that's our water levels going up. And on the x-axis is the net square displacement. And so that's how far a bird moved. So as you can see here, as the water levels go up, there's almost no movement. But as those, sorry, yes, that's correct. But as the water levels keep staying at zero, those birds start to move more. And then in the 2023, there was, again, negative in the fall, but there was little pattern elsewhere in seasons. And so we think with this, they are keying in on foraging availability. Fresh marsh does see a delay in flooding. So it could be that these acute water level fluctuations that we're seeing, that rails are not keying into that. They're keying into the duration of the water on the landscape. So how long that water is. And we do know that water, tides, flooding, they bring in a plethora of prey. And that's really what these birds are honing in on. Trying to get whatever is the energy bringing in from that. Also, the drought effects from 2023 could have had an effect on the no patterns that we saw during that year. Something else just could have been correlated with movement in that time period. For our hybrids, we really saw no pattern overall. Displacement really was just all over the place. It wasn't correlated with water levels that we could see. In 2022, there was a slight positive correlation, which just means that as water levels increased, so did movement, but it wasn't significant. And in 2023, there was no pattern at all. And again, this could be because of the drought effects. 2022 was a very dry year. 2023 was even drier. Another thing that we could differentiate with this is that intermediate and brackish marsh just could be different. And these birds are utilizing those two marshes differently. For our clapper rails, our salt marsh species, the displacement varied by both season and by year. So again, in 2022, there's a seasonal difference. There's a positive correlation. So high water levels, a lot more movement. But as we go just a couple months later to the fall, the opposite. As water levels stay around zero or go up, there's less movement. So again, just kind of to look at that pattern. More water, more movement, less water, less movement. In 2023, they had the inverse. So as we saw in the fall of 2022, it was a negative correlation. 2023, exact opposite. So we know that the drought probably had an effect when it came to this year. But obviously, we have to take into account that salt marshes see a lot more tidal influence and fluctuations of salinity from flooding, from rainwater and everything else. So there is a correlation between displacement and movement with rails, but we also do have to understand that there could be some other things factoring into why these birds move. For common gallinules, these guys the displacement again varied across seasons and years. In 2022, there were seasonal differences. They basically mimicked clapper rails. So there's a positive association, and then in the fall, there's a negative association. And then again, back to winter, it's positive again. So these guys are keying in probably into the submerged aquatic vegetation on the landscape. That's really where they forage, and it's also where they nest. And so if the water levels are kind of influencing the submerged aquatic vegetation on the landscape, these guys are going to react to those shifts. In 2023, if there was more water on the landscape, there was displacement for all seasons. And so there was no seasonal variation in there. It was a positive relationship overall. And again, we think that the drought could have had an effect on the SAB. We know in 2023, salinity started to creep up into these intermediate and fresh marshes from the Gulf, just because there was no freshwater inundation from the river or precipitation. So the salinity either could have affected the SAB on the landscape, which meant more movement. That's something that we think is our theory. Purple gallinules, last but not least, they saw that they differed by seasons as well. We had no birds in 2023 for these guys because they are migrants, and so they left in the winter time, and unfortunately, some did make it to Mexico, which was exciting, but a lot did perish on the way across the Gulf to Mexico. And the ones that did make it to Central America did not make it back to Louisiana. So we had no birds for that year, unfortunately. But regardless, we did see a pattern here. It was negative, but it was slightly kind of discombobulated. But as there was less water, there was more movement. In the fall, it's inverse. More water, more movement. But we think this probably has more to do with their pre-migration behavior. These guys are staging, they're moving more, they're just either going south, they're following some kind of pattern that's probably maybe associated with water levels, but more than likely is associated with their pre-migratory behavior. So for our home ranges, the home range size, it's cut off there. But overall, our winter home ranges in purple for all of our species were larger than for fall and winter. And for our breeding home ranges, those were smallest pretty much overall for all species as well. That was kind of the overall takeaway. But for rails from our generalized linear mixed models, an increased variability was associated basically with smaller home ranges. So as you can see here on the x-axis, as water variability increases, so basically water levels go up and down a lot steeper as you go to the right. And then on the y-axis is predicted 95% home range. So you can see there's kind of, there's like a divot in the beginning. So as water variability gets to about 6 centimeters, home ranges decrease. As you get to about 6 to 10, it jumps up again. We're still unsure about why that is. Me and a lot of other people are kind of parsing through that. But as variability increases past 9 centimeters, those home ranges start to plummet again. So we see that variability is pretty important to rails and to how small or how much space they use. There was also a seasonal interaction. We saw the largest shift in the winter, but the pattern was seen in fall and winter as well, just not as drastic. Vegetation type also affected home ranges. Surprisingly, rose cane and bull tongue had the smallest home ranges out of any other vegetative community, which included wiregrass and needle rush. For gallinules, NDWI, which again is just that metric of like how much water is on the landscape, increased home range, which was actually against our hypothesis. We thought that as there was more water on the landscape, the gallinules would have a smaller home range. So that was pretty interesting to see. But it makes sense. These guys are aquatic, but they need wetlands and they need marsh as well. What was really interesting with these guys was the max water levels interacted with variability. So this graph is a little bit hard to figure out, but I'll walk you through it. Again, on the x-axis is the water variability. Y is the predicted home range, but the color of blue here is the max water level. So it's inverted for whatever reason, but as it gets lighter, the max water level is going up. And so what I really want to show here is that there is an important interaction about how much the depth there is to the water levels, but also the variability within it. And so as those two coincide, that is really making a difference about how large of an area gallinules are using. So like right there, as you can see, the max water level is about 50 and the variability is pretty low. So their home ranges are going up. So probably the reason for that is just there's not enough SAV. Conversely, over here, water variability is getting high. And max water levels are about 100. So that might just be kind of the perfect mix of what they need. So the takeaways for this chapter that I really want everybody to take away from is that dynamic water levels are important for all marsh birds. And they are keying in on shifts on the shifting levels up, shifting water levels. Rails are particularly sensitive to changes in water levels by season, and gallinules are aquatic, but they will displace if there is too much water on the landscape. And so what I'm currently working on, my abundance estimates, I'm just going to walk you through how we went through that. We actually used 72 CRM stations as our reference points, so we could use all the information from them. And from those, we created 4 points to have 288 points that we surveyed every year, 4 times during the spring season. So that accounted to about a little over 3,100 surveys over the course of 3 years. And this is also across the 5 basins that you see here in southwestern Louisiana. We used a protocol from Conway et al., callback surveys, 13-minute callback surveys. Which basically is just a 5-minute passive listening period. And then for 8 minutes, a marshbird call is called for 30 seconds, and then you listen. Just because I'm probably preaching to the choir, but these guys don't call like songbirds. You have to elicit a call usually from them because they are territorial. And once we did get to our plot point, as you can see here, we took a water level with a meter stick at each of our survey times. I also kind of wanted to show you that even though we did walk into the marsh, we also did it by boat at times because these guys were randomly generated, the points were. I also kind of wanted to show you the fun times we had. We boated to every single one of our points, every single 288 of them. And this included dragging boats, push-pulling them, fixing them, walking in mud, walking through vegetation, and walking through both. It was a fun time, but also made me cry a couple of times, I will not lie. But overall, I can't complain too much. I saw a lot of Southwest Louisiana that a lot of people don't get to see. So very privileged in that regard. So for my statistics, I won't bore you too much with this, but basically I used an N mixture model, and this just takes abundance covariates and detection probabilities and lumps it together. Usual like linear mixed models or linear models don't take detection probability into account. So this model does. And so that you get kind of better estimates overall or more accurate measurements. So with this for my abundance covariates, I again used NDVI and NDWI. I also calculated the area of edge at all of my plot points and the vegetation community. The availability covariates are our traditional detection covariates. So basically what is affecting us from either hearing these birds or not hearing these birds. And that was wind, temperature, and observer. And then if I like to make things hard for myself, so I added one more, and that was conditional covariates. And that's basically temporary immigration. Yes. Yeah.
So edge area, did you calculate that on GIS at some point?
Yes.
Okay, so that was a sort of stat.
Yeah. All of my abundance covariates, I used Google Earth Engine, Sentinel-2 to get all all of those for my plot points, those metrics for my plot points. Yeah. Thank you. So, yeah, conditional covariates, temporary emigration. Basically, we think that these birds are moving in and out of these plot points for whatever reason. So if you don't hear a bird at one plot point in March, but you go back in April and you do hear it, and you go back in May and you don't hear it again, we know that that bird was there at one point, and so they were at the plot point. So just because they were not there again, it basically takes into into consideration that immigration. And for those, we use the water levels that we took with our meter stick, monthly median and monthly max standard deviation from the CRM stations. And kind of give you an idea of how I did that. This is from our remote sensing imagery. These are NDVI metrics taken. The white is the measurement of the edge habitat on the landscape. And again, our water levels that we took. This is from one of our water level recorders, but most of them were from CRM stations. So exciting stuff, the results. What I really want to hone in here is from all of our 5 basins that we had detections at. Let me orient you real quick. Y-axis is the average detections per site. As you can see on the map up there, a lot of our basins differed by size, and there were a lot of differences in points by basin because of that. So that's why we used average detections. And on the y-axis is basin, and it's color-coded by year. And what I really want to point out here is the Mississippi River Delta. This was our most productive basin out of every single one, and it's also our smallest. But gallinules were absolutely loaded up in these areas, and king rails. We had our highest detections of king rails in the Mississippi River Delta compared to anywhere else. Our second most productive was Breton Sound, and then Barataria, Pontchartrain, and Terrebonne kind of pretty much were similar but varied by year. What I also wanted to say was that in 2022, our average detections and within our models showed a negative trend during 2022, which makes sense because Ida hit in 2021. It completely went across our study area. And so we did see a dip in detections across all basins, but thankfully in 2023, almost everywhere, those numbers did recover, which was good to see. But again, the Mississippi River Delta only had a slight dip in the number of detections compared to everywhere else, like Barataria or Breton Sound. So this is basically kind of showing you what are the most important variables when it came to my N mixture model. As you can see here, this is for common gallinules, and this is basically it's a negative effect on abundance on the left, and on the right, it's having a positive influence on abundance. It varied by species and by marsh type, but year, obviously, we talked about that. But this interaction between NDWI, or the water on the landscape, and edge also had a pretty important effect on abundance. And so basically what this is showing you, that spline 1 is basically no edge. It's all land. There is no water on the landscape. The second one, spline 2, is what we call a hemi-marsh. It's basically 50-50 water marsh. Third one, all water. So as you can see, for gallinules, that first spline where it's pretty much all land, it has a negative association on abundance. That second one has a positive association, and the third has a slight decrease. And that was kind of a common occurrence across all of our species, including rails. As you can see, like I talked about the vegetation community with our movement data, roseau cane had a big spike in abundance for common gallinules, but it also for our rails. And this is an example from our cling rails. You can see here with the NDWI and edge, kind of similar, well, it's actually, it has a negative in the spline 2, but a positive in spline 1 and 3. Year 2022 and 2023 for cling rails had a negative effect on abundance. But across all of our rails as well, not just cling rails, the amount of NDVI was incredibly important for abundance, which makes sense. They're using the interior of the marsh. So, And last but not least, I just wanted to point out again that not only for movement is water variability important, but also for abundance. Both of these had a high effect on abundance across all species. So really what I wanted to end with for my presentation is that linking patterns to waterbirds is incredibly well studied and it needs to be continually studied, but linking processes to waterbirds is also just as important, and it is emerging within research. They are looking at the effect of waterbird variability in the Everglades with wading birds, and also in waterfowl with management. And so it's imperative that coastal engineers and biologists come together to look at how these processes can be used in the coastal master plan and these marsh creation projects so that these birds are able to persist into the future. So with that, I would just like to acknowledge first our whole entire team. We had a crew of 8 every single year. These guys were amazing. Could not have done it without them, including Ayla Lipford. She was a master's on our project. We tag teamed the whole thing. And also the Louisiana Technical and Implementation Group, my funding agency, John Weeb and LDWF. He was basically my biggest cheerleader for this project. And with that, I will take any questions. Hopefully it wasn't too much. It's a lot of information, so I probably flooded you with a lot. Yes.
I don't know if you can go back
Yeah.
easily without like the one by one. I'm not gonna remember how to ask the question, but in the ranges. The
Yes.
swing rails showing.
I think I,
Heavy pattern
yeah,
with, I don't remember what. This is probably the big one.
I think I messed up. Hold on. Maybe. Come on. Are you able to see anything?
Yeah.
Okay. For the home ranges,
It seems like.
sure.
So basically, I can ask it before it comes up.
Yeah.
I can't ask it with all the right words. So I was wondering specifically with the swing rails.
Mm-hmm.
Really showed like no pattern with, I think, water.
Yeah.
For the range lines. I wondered if that was because they're clinics, because you might be getting counteracting effects between flappers and.
Yeah.
Was that something that because it's not down the species, you might be getting some washout effects?
Sure, yeah. Let me just for the Zoom people, had a question about the clean rail results from the home range movement and whether, because we lumped them in together as a hybrid, whether that could have the speciation could have an effect on whether we didn't see a pattern. And I definitely think so, because I don't think every rail that we captured in an intermediate or brackish marsh was a hybrid, but we can't say without taking a blood sample and doing a DNA analysis whether it was one or the other. So that's honestly something I didn't think about. I was kind of honestly just thinking about the wetland itself. But I think, yeah, I think it definitely could have confounded those results. But at this time, unfortunately, there's not much we could do within that regard.
Did you pick colors?
Didn't take that, we took blood. And so we are thinking of, I just don't think we have enough blood to get enough of a panel is the only thing. And so yeah, I mean, there are some people that I've talked to in different areas that don't even believe that. They believe that all rails within the coastal marsh system in Louisiana are not a pure king or a pure clapper. So it's kind of that gray area, you know, so that's kind of why we did it that way. But I will say for my abundance modeling, why I think that parsed out a little differently for my species was that I basically modeled within marsh type. So I did my fresh marsh and whatever species were within fresh marsh and did that, intermediate, brackish, and saline. Because I didn't have enough data to parse out that way from my movement, and I lumped all the marsh types together, that could also have an effect on that. But you kind of just have to kind of do the pros and cons with that. Yeah, good question. Thank you.
Scientists, because a lot of the parts, almost any of the graphics.
Yeah.
That show like something when up at low water levels, and then, yeah, any of those. So to me, mostly, and you know, I'm a scientist and I've done some modeling, but not specifically with these. And even backtracking to the previous, yeah. And you balance and also have
Actually, no, you're good.
I'm curious how this will present to really scientific
Mhm.
audiences that are within modeling of the graphs and others who are less so. Even to me, some of these sort of look like it's a real stretch for them. Is this something that over time, working with them, you start to really see patterns that are clear? Or are you really working on values?
So
Because some of them look a lot like almost everything's in one category, and you're really sort of maybe drawing inference for the few inputs outside of that.
yeah, within,
That's not a criticism, it's more just like I know when people see.
yeah. Well,
and-
with,
and they're
yeah,
not clear, it's really hard to interpret how you get a message from that. That's weird.
right. It's hard. So with these results for the net square displacement, I tried to find a good way to show these results, because there's another way that I graphed it as well that kind of showed the dual movement spikes with the water levels. But everybody I showed that to was even more confused. So this is really, it is hard. And I do want to show, like, this kind of shows you the Pearson's correlation analysis that I did. And so the R squared value is pretty slight, and the p value is there. And so within my manuscript and with my dissertation, what I'm also getting across is that there is a degree of correlation within that as well. So like some of these, it'll go. It won't, hold on. Like a couple of them were about 0.3 or 0.4 when it came to the correlation. So that's kind of a higher measure of correlation than just 0.1. I think it's the movement chapter for this was kind of, it was my idea that was tacked on at the end of the first year. And I really wanted to kind of see what these birds were doing. And so I will say it's not the best. We could have what's the word? Created the project a little bit more linearly if I had enough time. But what the funding agency, what the main crux of my project was the abundance estimates, the callback surveys. And so I don't want to say it's a reach, because I do think that there is an effect there when it comes to water levels, but there is a degree. And I do think there is some confounding when it comes to other factors on the ground, such as vegetation. And I think you can get into that with the home ranges as well. It kind of parses that out. But I will take any recommendations of how to show my net displacement results, because I have yet to find anywhere on the internet that kind of show a very easier way to show it. I don't know if that answered your question. But... Yes.
Looking at that image, I wonder if it's determined that Within some areas.
It's, yes, so basically what I used Sentinel-2 imagery, which is a 10-meter resolution. And so it basically takes, so if this was, it's not at 10 meters, but if it was, I calculated NDVI for the whole entire area. And then you basically take a threshold value, and anything below that threshold value is water. And so it basically masks that out, and then it measures what's water to the edge and just maps it out there. That's kind of like a rough explanation, but it is as much, it's the only public, it's Sentinel-2 is what I could use, and it's a 10-meter resolution, which is obviously not perfect, but you know, it does a pretty good job when you overlay it across satellite imagery. But it is using remote sensing. So there is, you know, some error with that as well. So.
So were you putting out your tracking devices from the beginning?
We started in 2021 with just our surveys, and then we got our approval to put tags on birds in 2022.
Can you describe the type of?
Yeah, they were low tech GPS solar tags. So basically they uploaded up to a satellite and we remotely downloaded them. So we didn't have to get them back. And they did have a solar panel, so they were technically could be used indefinitely, but they do degrade over a while. And we use Teflon ribbon to put the tags on the birds as well.
And then so how much life we didn't have?
Oh, so for our rails, we did it for every 6 hours, and for gallinules every 4 hours. That it pinged a location.
Yeah.
And then it depended on every specific one, but about the average for rails is it lasted about a year. But like I said, we had about 3 that lasted over 2 years, and we have one that is actually still going. So that's about almost 3 years. So common gallinules was about the same. We have no common gallinules that are currently pinging anymore. So, but we did capture rails in 2022 and 2023. But we captured our allotted amount of gallinules in 22. So, yeah.
And then other master student already attending. You are done with your data collection.
Yes.
Does anybody else contribute?
I think they are wanting to extend it out to keep doing surveys, but I think they want to look at some other questions. I don't know what those are. I think they just got the approval to continue it on, which I hope they do, because they need to. But yeah, there is definite want to continue the project and probably extend it to other marsh birds as well, like seaside sparrows and other birds as well. So
There are reasons to do that in a fairly, I mean, PhD is a long time frame, but the data collection period is fairly short in the sense of whether.
yes.
And on that, they were two extreme routes.
Yes, and our 2021 was high water.
Right, and so I wonder about like how much that too, like we get that maybe like a ability, and some of that's gonna be provided in patterns. If you have one year of high water and 2 years of drought, it seems like trying to pick up a few more years to figure out.
Oh, definitely.
Then looking at year effects, that's maybe good.
Yes.
Time high water years versus how much is different.
Definitely. I really wish we could have gotten I wish we could have gotten tags out in 2021 when we had higher water levels, because we had a lot of rain that year and a lot of flooding. So I think it really would have been a good, contrast. But unfortunately, ecological studies do not like to cooperate. So, and I think every one of our years is different. No, they don't. No.
Well, I do want to get out of school eventually. So.
Yes. Yeah. Yeah, our movement chapter, I mean, I will say that I thought our movement chapter was gonna be a wash. I didn't think we would get really anything out of it. And so seeing at least some patterns come out of what we're seeing, especially with the home range and some with the movement, was really exciting to see, just because it was, in my opinion, we did the best we could, but it was a little slapdash. And it was kind of tacked on. So it's my pet project, and I am excited to at least get something out of it. So, but the abundance stuff is still pretty exciting as well. That's where all our work went into. So,
Season 5, I will start with the speakers. I've done those surveys, and the speakers are so,
especially because they're not waterproof. Yeah. So we basically had everything in a dry bag, and that's why pretty much everybody else was wet except for the dry bag. So you just like see these people, like all of our technicians just like walking like this with a marsh. But yeah, they're terrible. I don't know why they don't make waterproof speakers yet, or if they do, they're very expensive.
Yeah.
Fox Pros. But yeah, not great. Every once in a while, they would just play coyote calls in the middle of the survey.
I
So
feel like I struggle to detect the birds after the play that.